Yeah, good afternoon, students. How are you today? Okay, without wasting much time, today we are going to look at the topic partial fractions, which is one of the most important topics. As an elective math student, you must know it as a matter of fact. Now, by way of introduction, as a senior student, you already know how to combine two simple algebraic fractions to give a single compound fraction. If you understand that process, then you will have a knowledge of what partial fraction is all about. If I give you two simple algebraic fractions, for example, 7 over x plus 1 and then 4 over x minus 3, and you are asked to combine these by summing them up to get a single compound algebraic fraction. What do? I add them up. Now let's add up these two. We find the LCM of the denominators of these two fractions. Once you understand this process, then you have a knowledge of what this topic is truly all about. How do I get the LCM of these two denominators? Just pick the two denominators and combine them together in this form. X plus 1 in brackets, x minus 3 in brackets. Now let's find the numerators. To find the numerator, first of all, divide this LCM by the denominator, which means this will cancel this, leaving this. Now multiply this by this numerator. We have 7 into bracket x minus 3 plus. In the same way, divide this by this. So this will cancel this, leaving x plus 1. Now multiply this by the numerator here. We have 4 into bracket x plus 1. Now let's open up the brackets in the numerator. The denominator, leave it the way it is. Now let's expand this. 7 times x. We have 7x plus 7 minus 7 times 3, 21. Our plus here. Expand the bracket. 4 times x. We have 4x plus 4 times 1, 4. Everything over the denominator. Now add up the like terms. 7x plus 4x will give us 11x. Then minus 21, the constant, plus 4, the constant, will give us minus 17 over x plus 1 into bracket x minus 3. This is my answer. If I combine these two simple fractions, it will give me this one compound fraction. In partial fraction, I'm expected to do the opposite, the reverse, meaning I will be given a single compound algebraic fraction, and I am expected to resolve it, to break it into its component fractions. If I do that with this, I will acquire this. This is all partial fraction is all about. You are given a single compound algebraic fraction, and you are expected to split it, to resolve it into its partial fraction. And I will make this my first example. But before then, you must know that in partial fractions, the individual partial fractions must be in the simple form, meaning they cannot be simplified or splitted any further into any further simpler fractions. For example, this fraction is in the simpler form. There is nothing you will do to this to break it down into another simpler fractions. The same thing with this. So every partial fraction must be in the simple form. And then number 2, every partial fraction must be a proper fraction, meaning that the degree of the numerator must be less than the degree of the denominator. The degree of the numerator less than the degree of the denominator. What does that mean? The power of the variable here must be less than the power of the variable here. The power of the variable in the numerator must be less than the power of the variable in the fractions in algebraic fractions. Now, before we take examples, you must know that partial fractions has 4 types. Types of partial fractions. There are 4 basic types of partial fractions. Partial fractions are classified based on the factors in the denominator. The numerator has no issue in this matter, just the denominator. The first one is non-repeated linear factors. I hope my marker is clear enough for you to see. The board here is dark. Non-repeated linear factor. It means that the denominator will consist of linear expressions, linear factors. Like this is a linear factor, this is a linear factor, and they are non-repeated. When we get to that, I will explain further. Number 2, we also have non-repeated, non-factorizable. Don't allow the terms to make you afraid. Factors. In this second type, the denominator of the compound fraction given to you will not be a linear factor. It can be a quadratic factor, cubic factor, or any higher degree of polynomial, but not linear, and it will be non-repeated. And that factor given to you will not be factorizable, because if I can factorize it, it will give me something like this, a linear factor. But if I cannot factorize the quadratic factor given to me, how do I split it into a partial fraction? When we get to that stage, we'll talk about that. Number 3 is repeated now, repeated factors. Don't forget the first 2 are non-repeated. This one will be repeated. Whether it is a linear factor, a quadratic factor, a cubic factor, but it is non-repeated. How do I resolve it? And then finally, number 4, we have the improper fraction. Improper fraction. Let me explain something here. If you are given a compound fraction to resolve into its partial fractions, the compound fraction given to you must also be a proper fraction. Meaning that the degree of the numerator must be less than the degree of the denominator. If you look at these 2, this one is power 1. If I expand this here, I'm going to have power 2. It will be a quadratic factor. So before you start solving or resolving into partial fractions, look at the fraction given to you. Is it proper? If it's not proper, it is improper. Then there is something you will do before you start resolving. Now let's take them one after the other. Number 1, non-repeated linear factor. Can I use it? Let me rub it off. Number 1, non-repeated linear factors. I'm going to use this as my first example. Like I said, resolve this fraction, 11x minus 17 over x plus 1 into bracket x minus 3 into partial fractions. Don't forget the answer I got here when I began. I added 2 simple fractions, and those 2 fractions are these: 7 over x plus 1 plus 4 over x minus 3. Don't forget that. By the time I am done resolving this, I will still get that. Now let's perform the magic. Solution. There are two ways I can do this. Let me give you the simpler one first, method 1. Our fraction is 11x minus 17 over x minus 1, so x plus 1, x minus 3. Now let's resolve this. When resolving into partial fraction, the number of partial fractions you have is determined by the number of linear factors in your denominator. I'll repeat that. The number of fractions I'm going to have, is it 2 or 3 or 4, will be determined by the number of linear factors in my denominator. Since I have 2 linear factors here, I'm going to have 2 separate fractions that will form the partial fractions of this compound fraction. And each of these linear factors will form the denominator of the 2 fractions. Which means I already know the denominator of my partial fractions. Now I want to find the numerator. Since my numerators are not known, I will use alphabets to denote them. So for the first one, I will use A, capital A. So this will give me A over this x plus 1. Then plus, we are summing them up. For the second one, I use capital B to denote the numerator. This will give me b over this x minus 3. Don't forget, the factors in the denominator will form the denominators of your partial fractions. All you are left to do is to find the numerators. So use an alphabet in capital to denote your denominator. Now let's proceed to finding the value of A and B. To find A and B, I'm going to clear off this denominator. I want to clear it off. And to clear it off, I will multiply both sides by this denominator. Don't forget, in an equation, whatever you do to the left-hand side must be applicable to the right-hand side. So clear off this. As you do that here, also clear off this. So multiply through by x plus 1, x minus 3. Okay, don't forget I'm trying to clear off this. So if I do that, I'm going to have 11x minus 17 over x plus 1 x minus 3 times this same denominator. We are multiplying through by this. So this times this. Equals, also multiply this by this. Multiply this by this. So if I multiply this by this, it will give me A over x plus 1 times x plus 1 x minus 3 over 1 plus the same thing with this, b over x plus 1 times x plus 1 times x minus 3 over 1. Okay, let's clear off now. Now if you look up, you'll find out that this and this are the same. So they can cancel out each other. This, we cancel this off. Then you have only this left, 11x minus 17 over 1, which is still this. So this remains 11x minus 17. I hope you are following me. Cancel these two, they are the same. Cancel them. If I have 2x times x, yes, we'll cancel x, okay? Leaving only 2. That's what we are doing there, but in the complex form. So this will cancel this, leaving this. In the same way, these two are the same. So this will cancel this. leaving only a times x minus 3, which will give us a into bracket x minus 3. I hope you are following. In the same way, here should be minus 3, x minus 3. This and this are the same, so this will cancel this, leaving only x plus 1. So we have plus b into bracket x plus 1. Now, we want to find our a and b. You can find any of them first. Pick any one you like. Let's find a first. To find a, it means I need to eliminate this b. So I will have only a left. And then I find my a. What do I do to this x? What value will I put for x here that will make this 0? Because if I can make here 0, everything will become 0. Because this is b times this. So what value can I put for x here that will make this x plus 1 0? If you're a fast thinker, it will be minus 1. Okay? But if you don't know how to get it, let me show you how to get it. You find the 0 of this, take x plus 1 and find this 0, meaning equate this to 0. Because I want to make here 0. So let x plus 1 be 0. Now collect like terms. Make x a subject. If I bring this one in, I have x equals 0 minus 1. I will get what x equals minus 1. So I will put the value of x here as minus 1. So I eliminate this and I can find b. So to find a, I will say let x equals minus 1. So anywhere I find x in this equation, I put minus 1. That is what this simply means. This will give you 11 into bracket minus 1 minus 17 equals 8 into bracket minus 1 minus 3 plus 8 into bracket minus 1 plus 1. This will give us minus 11. That's 11 times minus 1. Then minus 17 equals 8 into bracket minus 1 minus 3, as you know is what? Minus 4. Good. Then plus b into bracket minus 1 plus 1 is 0, which is what we are trying to achieve by making x minus 1. Now minus 11 minus 17 is minus 28 equals a times minus 4 is minus 4a plus b times 0 is what? 0. If you add up these two, you will still get this. So we have minus 28 equals minus 4a. Now we can find a. How do we find a? Divide both sides by minus 4. So if I divide both sides by minus 4, that will give me minus 28 over minus 4 equals minus 4a over minus 4. And also cancel minus. 4 into 38 is 7. Okay, let me do this one first. Minus 4 cancel minus 4, leaving a. That will give me 7. So our a is 7. We have found the value of a. And if you check, our first one there is 7. Now let's find b. The same thing you did here, do for b. To find b, I need to eliminate a, this a. I want to eliminate it. So what value of x will make this 0? So that a times 0 will be 0 as we did here. Then we can find b. As we said before, find the 0 of this. But if you are smart, just put 3 here. Because 3 minus 3 is 0. But if you don't know what to do, find the 0 of this expression. Collect like terms. X equals 0 plus 3. X equals what? 3. Okay? So our x is 3. Now to find b, we select x equals 3. So anywhere I see x in this equation, I put what? 3. Don't forget that. So 11x means 11 times 3 minus 17 equals a into bracket s, which is now 3 minus 3 plus b into bracket x is 3 plus 1. 11 times 3 is what? 33 minus 17. 3 minus 3 is 0 plus 3 plus 1 is 4. This will give us 16 equals 8 times 0 is 0. This will give us 4b. It is 4 times b. 4b. This will give us 16 equals 0 plus 4b remains 4b. Now divide both sides by 4. Am I too fast? It's very simple, okay? These are just basic mathematical principles, which I believe you know. For you to treat this topic, it means you know these basic mathematical fundamentals that you should know. So we are dividing both sides by 4. We have 16 over 4 equals 4b over 4. So that 4 we cancel 4, leaving b. 4 in 16 is 4. So our b equals 4. And if you check here, our second fraction, the numerator is 4. Now you don't stop here. But they say resolve this into its partial fraction. Now what are the partial fractions of this? We now come back to this expression. This equals this. Where you see a, we put the value of a there. Where's our a? 7. Where you see b, we put the value of b there. And then you are done. Therefore, final answer. Therefore, 11x minus 17 over x plus 1, x minus 3 is equal to, what's my a? 7 over x plus 1 plus, what's my b? 4 over x minus 3. This is my final answer. We have been able to resolve this compound fraction into its component partial fractions. I hope you got that. Now there's a second example which second way of solving this, which I won't go into now. It is called equating coefficients. In that second way, when I get to this place, I won't use this format, let x be minus 1. I will expand these brackets here, expand them, and then equate the coefficients. I will teach you that method perhaps in the second example because of time. Example 2. Example 2.